All right, so step one, go to the Remote Learning Resources folder and click on this Holt Physical Science Tech book right here. All right, when it loads, it's going to look like this. It might take a second because it's the entire textbook. So you should see up in the top corner here where it says 970. Okay, so when you do that, you're going to go. I want you to type in the number 83 up into this box, and it'll take you to a page that looks like this. So type in 83 in the box up top, and it'll take you to this page here. If you click on this fit to width button, it will expand so it's as wide as your screen, making it pretty easy to see and work with. All right, so far so good? All right. So next, I'm just going to go over this material. So it talks about physical and chemical changes, which is what we're going to need to review today. I originally planned on going over and into chemical reactions, so that way we can advance a little bit. But since we've been out of school, we're on and off for about a week, and I've been out, I just want to do a quick little recap so we can all get on the same page moving forward. So, chemical changes of matter. All right. So I'm gonna come down and basically talk about. I'm gonna summarize this stuff. I'm not gonna read it all, but I'm just gonna do a summary. So hopefully that'll help you out. So a physical change is a change that affects one or more physical properties of a substance without changing the identity. So a physical property is how it looks, how it feels, anything you can observe with the senses, look, feel, taste, all that stuff. So if you go down here, you can see three pictures. One picture is ice melting, all right, so popsicle melting. All you're doing is you're changing it from a solid form that's frozen to a liquid form that's melted. If you cut your hair, that's another good example of you're not changing anything about it. You are just changing the color, or not the shape of it. If you color your hair, like you bleach your hair, all right, that is a chemical change, but just cutting it itself is not. Crushing a substance like a pop can, you could uncrush the can, but all you did was you changed its shape. The can is made of aluminum, and all you're doing is moving it from a bigger size to a smaller size. So that's a good example of physical change. Here's a few more up here, where you got sanding a piece of wood, dissolving sugar in oil, and this stuff here. So those are all other good examples of a physical change. If you've ever seen anything get melted down, this stuff's pretty cool. If you look it up on YouTube, like where they melt iron down, or I know there's a few documentaries or like shows on Netflix that have melting metal. That's pretty cool. I know there's like a reality show where they make different swords and things out of metal, and you get to see them melt the stuff down. It's pretty cool. So all you're doing is you're taking it from a gold nugget or a rock and turning it into a ring by heating it up and changing its shape. That's a physical change. So I don't know if you remember that when we dissolved the water, the sugar and the salt and the water, what we did there when we did that lab was basically what's kind of going on in this small picture right here, is that this solid crystal structure here on the left is what it looks like when it's in solid form. So when you look at sugar or salt and it's in that white cube form, that's how you know that it's in a solid form. But what water does is it ends up pulling the molecules apart one by one and separating them into the water. So it looks like it disappeared, but it's actually still there. Each molecule has kind of been hijacked by the water and pulled apart. But if you get rid of the water, you can have the substance reappear. So in salt water, if you dissolve salt in water and then boil the water, you'll be left with the salt inside the pan. So it's a good way to reverse that process. Anytime you dissolve something, it's a physical change. Keep that in mind. Anytime you dissolve something, it's a physical change. Okay, chemical changes is up next. A chemical change is a change that happens to one or more substances where everything about the substance changes. It's a new substance entirely is created from a chemical change. So some quick chemical changes we can look at here. All right. So sodium and chlorine. Sodium is a very reactive, dangerous metal, and chlorine is a very poisonous, harmful gas. All right. So here's what happens when you mix sodium with water. Massive explosion. You see a lot of fire, a lot of gases produced. You can see the fire on the water right here, and then a massive explosion. Okay. Chlorine. It was used in World War I as a weapon because it very, very painfully kills the opposition. So chlorine is absorbed into the lungs, where your lungs are wet and full of moisture. That moisture reacts to chlorine, creating more chlorine solution like bleach, and then you die of asphyxiation or suffocation. Very painful, very harmful, very terrible. It's actually illegal to use chlorine gas in war nowadays. However, if you take this burning piece of sodium here on the right and you combine it into this chlorine gas that's inside this tube, they'll react. Now notice the chlorine gas is not escaping from the open tube, because if you look on the periodic table, whoa, wait a minute, what? The periodic table? Chlorine weighs more than oxygen, so it's going to sink to the bottom and not float out of the tube because it weighs more than the air that it's in, so it's going to sink and not escape the tube. So you can see him heating up the piece of sodium over here, and he's going to place it inside the chlorine. Obvious chemical reaction. Lots of gas produced. That jar is very hot. There's light being emitted, and there's also a new substance being formed right in the middle of all that. Fast forward a little bit. What comes out is this white powder, and that's called table salt. That's the stuff you put on your French fries and your food. Okay? So this is chemically produced table salt, the stuff you can sprinkle on your food and eat. You can eat it. You actually need salt to survive and live. It's your body uses it for a lot of stuff. So it's very important to your body, and it's easy to eat, not harmful for you at all. But those two chemicals separate are very harmful for you, and which is indication of chemical change, is the properties of it changed entirely. So let's move on to the assignment for today. All right, so if you go to this folder here, chemical changes, where it says remote, and you go down to chemical and physical changes, this assignment right here, it doesn't matter if it says Bell 5 or Bell 7, it's both the same assignment. All right, when you open this up, all right, you'll see basically what you're doing here is you have several different situations. I'm just going to give you all the situations, and all you have to do is tell me if it's chemical or physical. I know this looks like a lot, but the only reason it looks like a lot is because the type of problems that we used. All right, so that's it. All you're doing for this is putting down a chemical or physical or true or false. It's really simple. It's not as bad as it looks, I promise. So up top, I give you what I'm looking for. If it's a physical property, you observe it with your senses: touch, taste, sight, smell, kind of stuff. It's determined without destroying matter, and phase. There's a phase change. It goes from a solid to a liquid, liquid to a gas, stuff like that. If it's a chemical property, it indicates how the substance is changed into something brand new, and the matter will be changed into a new substance altogether. So, for example, blank 1 matches with question 1 and 2 on. So if you click on the blanks, it'll highlight the space that it's referring to. All right, so for example, number 1, blue in color. That is something we can see. All right, so we don't need a chemical reaction to take place for that. So that's a sense. So I'm going to put down P for physical. It doesn't matter if this is capital or lowercase. All right, so weight. Weight is something you can observe by touching. All right, which is also a physical change. Flammability. Anything that ever burns is a chemical reaction. Anytime you burn something, you get bright light, you get heat, and you probably get some sort of gas that's produced. So that's always going to be a chemical change. Just like I said, that's always a chemical change. Dissolving is always a physical change. It's P. Okay? So what about reacts with acid? Is that a chemical or a physical thing? You can shout it out.
Chemical.
Chemical. Very good. Reacts with acid is a chemical thing, so I'm just going to put down a C. Okay? So that's how you can go through and do these ones here. It's just a C or a P. That's all you got to put in. Same thing here. All you got to do is put down C or P. I give you a situation. You tell me if it's a chemical change or a physical change. So a substance that was ice is put in the sun. It is now a puddle of water, and then later the puddle is gone and it evaporates. That's a phase change, going from a solid to a liquid to a gas. Is a phase change, so it's going to be P. And you just keep doing that all the way down. So two chemicals combine together, form a gas. That's chemical C. All right, same thing down here is over here. So we got chemical and physical changes. All right, tarnishing, I will point out, that just means to rust. So like we talked about, rust is a chemical change. Tarnishing is silver's version of rusting. It gets dull and kind of ugly looking. Cutting an apple is a physical change. So again, all you do is you're matching where it says to, is it a physical or chemical change, by putting down P or C. And then finally, we got some true and falses. All you gotta do is type in true or false. All right, changing the size and shape of a piece of wood is a chemical change. Is that true or false? Hello? False, correct, thank you. Okay, and that's all you gotta do, is type in true or false for these. A physical change, the makeup of matter is changed, so false. Evaporation occurs when a liquid turns into a gas. That's true. And that's how you go through and do these ones. All right, so you get 5 attempts. It says up here in the instructions, you have 5 attempts to get the highest score possible. Only your highest score is what's recorded. All right, so out of the 5 attempts, your best score will go in the grade book. Okay, so please use this time wisely today and get this done. I will be, remember, I have my office hours from 2 to 3 o'clock. So you can log in and I can help you with that here. Highly recommend you give this a shot on your own one time. So try it on your own without my help at all. And then come to my office hours and we can talk through your answers and I can help you out. Okay? So if you have any questions, now's a good time. Okay?